think we can start. Uh, Maybe let's start with Nathan and then go up.
Yeah. Oh man, I always get to be the first one, don't I? Here. Okay, so going up would be bad. I, ah, I mean, I'll be honest. I thought I had a better grip on all of this before I started trying to read that paper. I didn't see your comment about the other links until we actually had started. So I kind of got about halfway through the main paper. Um, and it's interesting, but I'll say I'm not a discrete guy or a cryptography guy, so it was a little bit. It's a little bit beyond me. I think I can follow about 30 to 40% of what's going on in it. But I did then take your suggestion and run it through Claude, and I should actually paste this in because I'm assuming it's accurate. It gave a pretty good explanation, which kind of aligned with my understanding, which basically just boils down to you can thinking about this as like polynomials, and it's almost like translating data into a polynomial space is kind of what I think about it as. And so, I know that if I have n data points, I can always satisfy these with a polynomial of n minus one. I now have this space of polynomials of n minus one. They're very large polynomials, like, you know, uh, they're on the order of like, 4095, I think. Um, but the idea then is, I can or actually, sorry, they're not 4095, 8192, because I forget they've been extended. So then the idea is that these extension points are still on the polynomials. So I can now start to sample these points. And if I know that once I have enough, I know I can reconstruct the polynomial and the original data. And it's very hard for an attacker, sort of a priori, to generate a different polynomial when you don't know which points I'm going to try to sample off of that. Because all they need to do is screw up once, and which is fairly likely. And I now know that I can get something back where I know I'm not getting a polynomial that matches um, the data that I do have access to. So that's kind of how I think about it in my head, which I know is like actually much more simplified. It's like leaving out the entire commitment process there. So there's obviously a lot more going on, and I don't want to like present myself as an expert or anything. Just to show you where I'm at, I just before we started, I was like, "Hey, Claude, can you actually explain cosets to me?" Because that's not a concept. Cosets is not a concept I'm super familiar with. Anyway, in terms of like architectural relationships, it I keep being struck more and more about how Ethereum seems to sort of follow ultimately seems to be following kind of the ancient dictate of moderation in all things. Like it really is sort of like, it's somewhere between get everything off chain and, which is kind of you know, to the extent that Bitcoin has an approach is what Bitcoin has been trying to do with Lightning Network and, things like Solana, which are much more like, we're just gonna have a really beefy chain. And we're just gonna optimize and we're gonna do that thing. And I think that moderation comes from, Ethereum actually being committed to um, both the concept of wanting to be a world computer and the concept of wanting to be decentralized. And that puts it under those are intention. And I think the fact that it keeps kind of coming up with these sort of more moderate solutions is something that kind of is indicative of how it's navigating that tension there. So that's all the thoughts I have. Nothing particularly deep. Really interested to hear what people who know more about this space like Ben have to say. So passing up to Ben.
Sure. So yeah, this is a so I kind of want to take a step back and try to explain why people are doing this and the goal. So the whole point is to try to increase scalability. Base layer blockchain, just everything is replicated. This allows everyone to verify everything, but means that the whole network can only be as fast as basically what you want a single node to be. And unless you wanted that to be like a supercomputer node, um, if you want something people can actually use that are not professionals, they need to be small enough, which means that the network is limited, which means that you end up with, if you're old enough like me to remember the high fee days of a decade ago, or not quite, well, mostly a decade ago. My point is that to split this up, you have to split up verification, and to do that, different nodes have to verify different things, and it turns out that's relatively easy. That's actually been done, I think, for like when did this stuff start? Like 3 or 4 years ago, when Optimism and Arbitrum and everything pushed out for something more release-like. And there's this like somewhere there's something that says, all right, this is how robust these sort of rollups are. And the way it works is that the rollup publishes a bunch of blocks that they choose. It's called sequencing, and then everyone there's the system either through a zero knowledge proof system where you just verify the proof and then all the transactions they've published are verified without having to verify each individual one, or you have some kind of optimistic system where you assume them or until someone scans and gives a proof that hey, this is actually incorrect. Um, that the sort of distributed verification turned out to be relatively straightforward. The hard part becomes into what's called data availability. Basically, it's something that no one was even thinking about until you start looking at systems like this, which is to say, how do you know that all this data exists and that you can access it, particularly if you need to fork or something. So if the sequencer is bad, how do you make a new sequencer? You could hypothetically, just take all the data, get to the chain tip, and whatever that is, and then continue from there. But that requires you to be able to download all the data, and knowing the data is correct is not good enough for that. You actually have to have the data. And the threat model they were really worried about was, all right, a bad sequencer, one entity, so very easy to control, um, creates valid stuff, but then doesn't publish it at all. Doesn't release it at all, doesn't do anything at all with it. Just produces the proof or releases the block header or whatever. Um, and because not everyone is downloading everything, then this will actually be able to get through. And that was a big worry because it's a n bad actor. Like a single bad actor could basically screw up the entire system. So that was a critical vulnerability they were, and that turns out to be very hard, or at least much harder, because and I would actually argue that pure DAS doesn't quite solve it, but is a lot better than nothing. Um, but it's hard because it's hard to know like someone is storing data from you for you somewhere else without fully checking the whole thing. But the way pure DAS is supposed to work and the way data availability sampling is supposed to work is that technically speaking, there's a bunch of cryptography stuff. I don't want to go into it too much. I don't understand it very well, but I do know polynomials. And one of the features of polynomials is that if you have a polynomial of a certain size and you drop certain numbers of points, you can actually recover using the other points, the missing points. It's a very basic thing that you can do with just sort of polynomials in general, and therefore this leads to this ability to, all right, if you like encode your data into a polynomial, then extend it so you have like sort of extra points. So there is some overhead here, but it's not that big. Um, and then using these extra points, you can lose say a certain number of points and then still reconstruct the polynomial mathematically, which means that you sort of recovered the points you lost, which means you recovered the data you lost, which means that as long as you have enough out there, um, you can still recover the whole thing. It's not you don't have to worry about the situation where the bad actor publishes everything except a little bit, and that little bit, you can't actually reconstruct the chain and fork from them without that little bit. But if and it wouldn't be immediately obvious that little bit was missing. unless you are checking absolutely everything. Um, and the way this erasure coding works is there is no little bit you can take that you don't publish that can't be recovered. So no matter, even if they leave off and never publish certain pieces of data, um, basically the idea is if they do that with a large quantity of data that the encoding couldn't recover it, it would be obvious, and then that would be rejected. Um, or if they publish a small amount, then the encoding just fixes it and heals it naturally, and then you don't have any problem. Basically, what you've done with the data is you've put it in such a way that it's all sort of interconnected in such a way that you can always recover a little bit of it from or the whole. The idea being that now you have this really robust thing, this really robust data set instead of just arbitrary data where if you lose a byte it's gone. And then you just have it so each node probabilistically downloads data from each other. And then if they hope that if I download like bunch of little pieces, that means that these I hope the full thing is actually out there. Now what this doesn't solve, and I guess you can see it like some reaching over there in terms of I'm looking at the ethereum.org page where they talk about supernodes. So this sort of says that all right, we know that data was published at that time t where when the block was created. It really has no guarantees and cannot have any guarantees for that the data will continue existing and being available for time any t plus t prime or t plus n, or you basically there's no reason to believe that the data couldn't all be deleted in the future and then lost. This can't sort of handle that because that would you don't know what people are going to do in the future. And the idea is that raw data storage is not that hard and not that expensive. Like so if you go to Data Hoarders Reddit or just buy yourself a big chunk of old spinning magnetic plates, and you can probably store many petabytes of data on that. And the whole idea is that the whole network, even if only a handful of people do that, as long as one survives somewhere, and of course like the Ethereum people themselves, Ethereum.org can run one of these. It's not that expensive. Um, then you're certain that in everything in the far future nothing will be lost. There's also in the future you don't actually need a lot of this old stuff because if you had to do something, you'd almost certainly be restarting from a point not too far from the what you thought that was the chain tip. But as you try to split things up, things always get more and more complicated. So um, this is like I said, I remember reading the post from Vitalik about how this was first being created, and I thought it was pretty clever. And I'm glad to see it's actually getting to the point where it's hammered out enough to go into production, and they're doing stuff with it. Um, yeah, I think that sums up all my thoughts on it, and yeah, I'll pass it up.
Yeah, so I didn't read the mathematical parts, but I tried to read the historical context of why it was needed, and then how kind of it was implemented. So what I understood was that initially all the rollups and L2s were storing the data on the in call data, and this was increasing the gas prices. So they introduced something called blobs, but still the all the nodes still needed to download all the blobs. And so basically PRDAS was implemented to clear out this bottleneck by using some polynomial functions to basically make a polynomial, and then the nodes may, I think, download like 1/8 of the data, and then you could sample it from different nodes, and then basically verify if the everybody has the or if the data is correct or not. So basically, like this is like a scaling mechanism for L2. That is what I understood. Uh, what else? Yeah, but like what Ben mentioned about like if in the future somebody is not keeping, if we don't have access to the data, does that mean that like if I make a transaction, let's say on base, and they remove my transaction or some transaction history in like 10 years from now, that base transaction or some other L2 transaction goes away, right? So that was like something that came to my mind. With that, I'll pass it on to Anand.
Yeah, thank you. Yeah, I didn't get far with the actual paper. I did try to start reading the paper, and the math was uh, it was an easy read, so I decided to just read the simpler explanation and use ChatGPT. And I guess like one thing was telling for me personally was it just takes like some time to even get oriented if you're not actively living in this world. So I was trying to catch up on like what the next upgrades are and when this is scheduled and like so on and so forth. And that was um not very straightforward to find. But anyway, I think I get the essence, get the intuition based on what I've heard from all you guys and what I could sort of muster from my ChatGPT conversations. Like I could get the essence that this is a way to sort of reduce uh, the sort of strain on node operators at the L1 level. Like you can sample data instead of fully downloading it, but still guaranteeing the existence of it. I didn't quite understand the sort of issues that Ben was alluding to. I might have to spend a lot more time to get an intuition for that. But the idea itself seems sort of straightforward, and I could develop an easy intuition for it. And also, it is very nice to see the sort of the trilemma sort of getting solved with this, which I think is very interesting without compromising on the decentralization. And how do you make sure that you can continue to incentivize home stakers and other node operators without like extensive hardware constraints on them can continue to contribute to the growth of the network. That seems interesting. The other thing I read somewhere, I'm not sure again how true this is that the sort of the resilience of this it seems like the term of the day. It seems like the resilience of this approach it kind of grows over time as the network state grows in general. Uh, I suppose it's got something to do with the probability getting harder to fake for the availability of data or something like that. Like you could essentially have somebody's proof before. I don't know the exact the sort of the transition point mathematically where that happens. But it seems like that's where the sort of eventual goal is. Uh, yeah, the last thing I was thinking about was like all things with Ethereum. It seems uh, I guess in general, all things very complicated stuff. It seems like you kind of need to kick the tires a little bit to develop better intuitions. Just reading about it can only get you so far. At least I was thinking. I'm still yet to try my hand at running a node. Still a project. Maybe 2026 would be the year. But let's see. I'll pass it down to Venkat.
Yeah, this has been an interesting journey to watch. I think I understood less than all of you on the technical stuff. Uh, but at a personal level, I remember actually sitting in on the ETH R&D research meeting in Istanbul where this was actually hashed out. I think that was November 2023, and I think Danny posted the basic proposal. One of the links I think Raj posted is the basic proposal. That was sometime in September, so it was very fresh, and the discussion there was kind of interestingly fragile and uncertain. People were arguing. It was like uh, any regular detailed technical meeting at like a big company or something. So it's interesting to have watched the kind of socio-technical journey from that initial sort of like argumentative and debate stage all the way to now that it's like actually deployed to production, and Vitalik is kind of bragging about it publicly. So it's nice sort of proof that the ecosystem works. So that was good. People worked really hard on it from what I was able to see. Just fly on the wall. This is one of my privileges doing work for the EF. I get to be a fly on the wall listening in when they talk about this stuff. So I would say it's one of the healthiest technical organizations I've seen. It has its problems, but all the people there are genuinely competent, sincerely interested in like understanding and solving the problem right, and working out the trade-offs and compromises and getting it done, which is more than I can say about similar processes I've watched in many private corporations. But anyway, that's just a meta comment. Yeah, I think my understanding of the technology is consistent with what you all said. The polynomial reconstruction part seems like basically a trivial extension of what we all learned in high school, right? Like um, a straight line has two parameters defining it, and if you have two data points, you can reconstruct a straight line. Quadratic is needs three coefficients, 3 points is enough to reconstruct. So they extend that logic to, I guess, thousands. Uh, there's no reason not to. One part that's slightly unclear to me is I assume all this is happening in discrete space and polynomials are uh, basically floats, and it's not quite clear to me how discrete to float precision is handled when you do polynomial computations. The extension and erasure coding part is also straightforward. The part that I was trying to probe with ChatGPT but didn't quite understand, and I've tried this several times but I haven't ever fully understood it, is the KZG commitments. That seems like a pretty complicated thing. And yeah, I guess they call it dank sharding, proto-dank sharding, because there's a sharding element in the 1/8 distribution. Everybody keeps like 1/8 of the data around, but individual blobs don't seem to be actually sharded as such. Yeah, that part is not. I don't think it's sharded. Blobs are kind of kept together, I think. So if there are like n transactions with blobs attached in a block, I imagine like validators keep 1/8 of them around, but like keep entire blobs together or something. It's not, that part is not clear to me. What else? Yeah, I think it's worth clarifying that blob data is not meant to be indefinitely persistent. It hangs around for around 18 days, and it's meant to serve only securing the ledger type functions, not indefinite availability for whatever the payload is about. And the way I think of it is if you do a transaction at a grocery store and they give you a receipt, there's one level of checking you can do, which is like, did they charge you for extra items? Did they charge you the wrong amount for the items you actually bought? That's like a level of checking you can do right there. So long as you keep the receipt, you can do one level of validation. But a second level of validation is you go home, use the item, and after a couple of weeks it breaks, or it doesn't function as promised. That's not the grocery store's problem, or the store's problem. You may have to contact the manufacturer for like the warranty or replacement promise, or go to some other thing. I think the logic here is something like that. So the data availability sampling within the 18-day period is something like correcting errors in the receipt or being charged the wrong amount or something like that. And beyond that, there will still be a record that such a transaction existed and the amount, but maybe the receipt is not around and the itemized details are not around to cross-check. But the additional security of like, are you actually getting what you paid for? That's, I guess, the equivalent of manufacturer's guarantee and calling for a replacement if it doesn't function as claimed. That is my vague metaphoric understanding. I don't actually quite know how any of this is used on a practical level. Like, what do the L2s actually use blob data for? I actually don't know. So that would be interesting to look into. What are blobs actually used for? Because it looks like ever since 4844, when they were introduced, yeah, the market is saturated. relatively quickly, and it's now become price sensitive. So clearly, it's being used. I believe most of the blob capacity is being used by the stablecoin guys. Base in particular, I think at one point was using the majority of blob space by itself. And this PeerDAS type mechanism, yeah, it 8x's the blob bandwidth, and I think a couple more planned roadmap elements will keep increasing it. But there's going to be a fundamental limit. I mean, on-chain compute will never have uh, even this transient data capacity and availability that off-chain data will have. And here, I think it's interesting to make the analogy to um AI memory, right? AI memory is similarly bandwidth constraint. SRAM is the most expensive on-chip memory. Now there's like obviously big companies trying to corner all the supply of HBM, and even regular DRAM is now in like crisis mode. Like all the big companies are basically locking up the entire DRAM supply, and they're now more valuable than the GPUs and accelerators. So it seems like this is a general theme, just to sort of like reference our overall, distributed composable and distributed systems theme of this track. It seems like memory is the bottleneck at these higher levels too, not just the one Newman bottleneck at the low level, but higher distributed and composable systems. Memory is the bottleneck. It's expensive. The closer you get to sort of the core of the processing operations, it's cheaper. The further away you get in terms of like latency, and I guess the equivalent of like on-chain versus off-chain availability in AI, I'm not quite sure what it would be. So like HBM accessible caches for the entire inference cluster might be the equivalent of like blob data, and the equivalent of off-chain archival data would be, maybe GPT-3, which was a couple of years ago at this, or is it like maybe a year ago at this point. The training data for that might still be of like, historical value. At some point, you might want to go and ask what data was used to train GPT-3. That's the equivalent of like data that's important, but can be maintained quote unquote off chain in the history of LLMs. So something like that. I think there's a general theme cropping up here. Anyway, yeah, interesting deep dive, lots of like really difficult crypto math spots, but I think the overall idea makes sense and is clear enough.
Any more thoughts?
This isn't quite related, but I did. I think I said last week I was going to try using Claude. Actually pay for the subscription, and I've actually had a really interesting time with it. And I've got some notes. Obviously, it's not really part of this meeting, but if you want to like meet afterwards, I'm happy to talk a bit about it and what my experience was and what it makes me think about this AI stuff. So yeah, I might be around in 10 minutes to do that.
I'll stop the stream and then we can discuss that.